That looks like we've got it. And we'll start in just about a half a minute. And it looks like it's official. Welcome back, everyone. This is the start of the spring 2026 semesters. That's my first mistake doing that, I think. Let's fix that right away. Welcome to the spring 2026 semester, everyone. So this will be a pretty fun class. It's an interesting one, being fully online, but with set class meetings. I'm glad that you all made it in today. Any questions at all to start us out? Okay. Well, first thing I want to talk about is kind of what my setup really looks like from my end, what I'm seeing. What you're seeing on your screen and what I'm seeing on my screen is a little bit different. So first, let me give you just a view of what's going on here. Okay, so this will give us a good idea of how the class is going to run. And it gives us a good idea of what some of the challenges are working with this kind of environment. I only have one screen that I get to work with in my setup down here in class. And that one screen has very limited real estate, like you can see here. So the first thing I do is I usually just close this window where the red dot is. It takes up just too much real estate. And so that means you don't have to have your cameras on for this class. I'll leave mine on, but it's completely your option. So once I close that window, then the view updates to something a little bit more like this. So this is the screen that I'm usually teaching a fully online class from, that this is what it will typically look like. All the real estate's right here. Usually there's going to be like lecture notes that we're working on, so we needed all that space. I keep my eyeballs really focused right here. So this is a great place to start doing things like class participation, class reactions, those kind of things. You could use a thumbs up symbol or a hand raise symbol, anything like that, if you have a question, for example. But as far as participating in the class, you don't have to wait for me to call on you. Everyone is welcome to interject at any point using your microphone, and that would work out just fine. You can also use this feature up here. If something's wrong with your microphone, or if maybe the sound environment is just kind of busy right now and you're worried about that, dogs barking, for example, you're also welcome to participate just using the ordinary chat feature. So that will work out just fine. For some people, that might be a preference. Other people might be using class reactions here and then asking questions or making comments using the microphone, and that'll be just fine as well. If you do send a chat, it's a little tricky for me on my end because my eyes have to notice that this changed to one for one chat and have to actually physically click on it to open that chat. So if you sent a chat and you noticed I might have just sort of missed it, anyone in the class can interject at any point and just say, hey, Mike, you missed a chat. And that would be very, very helpful for me. I would appreciate it quite a lot. I get better at this as the class goes, but sometimes starting off a semester, I get a little bit rusty. So I'll try to keep my eyes here, watching out for chat. I'll keep my eyes here, watching out for reactions, see who's talking, that kinds of stuff, those kinds of things. And essentially, that's about what the setup is going to look like. If we're working on notes, this is a syllabus, it's not notes, but for notes, this is what the screen is going to convert to. We'll be just drawing on top of things in whatever manner to fill out the notes, making comments, and so on. Well, welcome to Math 1123. When you first log into class, usually it's going to also look like this. We'll be pointed at a Canvas page with a screen sharing already activated. I'll have a lot of different comments potentially. I'll try not to make the screen too busy. Too many comments is not always helpful. But usually I'll have a lot of like announcements just preloaded as comments ready to go. So what our goal is for today is really just go through the syllabus, talk about how this class is going to run each Monday, Wednesday, and Thursday, kind of an interesting set of days. We'll talk about how the homework system works, how to access the textbook, address questions, and if we have some time, we'll get into section 2A from the textbook, starting a few problems there. Well, I've already talked for about 5 minutes. Any questions or comments at the moment? Okay, well, let's start off with the syllabus. So pretty much this part right here, everyone's pretty familiar with since you made it to class, you're here, you found the Zoom link. If you have any trouble, this is for people who might be watching the recorded lecture later on, any trouble that comes up with technology, you can contact me at any point. I don't always check my cell phone too often, but for emergencies, it's available here. Best way to get in contact me is definitely through email. I'm checking this pretty much habitually throughout the day. I usually have a Chrome browser down here and it'll just switch over to a notification the moment an email comes through. It's like a compulsion. I have to look at that email before doing anything else. You can send to that email pretty much anything. It could be a quick question about the class. You might notify me something that might be coming up that might make you miss a day, anything along those lines. If you have questions on homework, questions on quizzes, anything at all, even math questions, feel free to just send it to that ISU email address right here. I'll be very happy to engage with you. Essentially, the email here becomes kind of like a alternative kind of office hours. But for actual scheduled planned office hours, they'll be through Zoom, 2:30 p.m. to 3:30 p.m., Monday through Thursday. If those times don't work out too well for you, just send me an email and we can make an alternative arrangement.
Oh, do we have to have our
Well,
cameras on?
any questions at the moment?
It took me hella long to get on here, dude.
Oh, I think that was just an open mic. Well, other things to talk about are the textbook is kind of unusual for this class. It's a fully online textbook. We access it through our MyLab account, so that's probably one of the bigger things we ought to start talking about before we get entirely through the syllabus. I think that's the main thing to get ready, accessing the MyLab math account from right here. So the way you can access this, it looks like about 10 people in the classroom, last I checked, have already gone through these steps, logged in. To get into MyLab, it's going to be through this button right here, Access Pearson. A lot of different things happen when you click on that button. You have to link your Canvas, paste your Canvas course to the textbook, and register for a Pearson account if you haven't done so already. But after you go through those initial setup steps, I'll give you a look of what this actually looks like, MyLab, once you're all set and getting in. So let's take a look at that at the moment. If you feel like you're pretty fast at getting set up, you might click on this along with me and start registering for MyLab. But this is something you can do, say, after class as well. So when I click on Access Pearson, this is what it looks like for me so far, since I already have the course linked up with the MyLab account. When I click on Open Pearson, if you've already registered for this, I'm going to just say allow continue to the cookies. If you've already registered for Pearson, this is the button you would see right here, just open MyLab and Mastering. If you haven't registered yet, you'll probably see different information on the screen for registering your account. And again, you can work through that right now if you like, or if you feel like you want some extra time to not get too distracted, you can do that right after class, and that would be just fine. If I click on this button again, open MyLab and Mastering, not again, click on it for the first time, allow and continue with the cookie settings. And again, geez, that's a lot of notifications. This is what it now looks like. So there's lots of stuff to talk about inside here. And if I click on this, this will be a little bit more familiar for what you'll see. This is what everything is going to look like inside the homework system, MyLab. We'll talk a lot more about this probably on Wednesday and Thursday, once everyone has had a chance to get registered in. I'll often just say MyLab instead of MyLab Math. It's kind of a long statement. So we'll talk a lot more about this when we come back on Wednesday and Thursday, once you have a chance to get registered. But for folks who would like to see where everything is right away, pretty much this is the experience. Once you're on Course Home, Our objective is to work through the homework sets. They'll be posted down here, get them to 100%, and then move on to the next. We're going to be spending all week on section 2A. It's a rather large section. You can work on this in chunks. You can work on this once we finish out the entire section 2A. It's going to be really up to you on how you feel like you might work the best with it. So if you click on that, that means you're starting the homework assignment. That's kind of rough to just jump right into a homework assignment. Usually a better flow for dealing with the math class is take a look into the section 2A first. See what all the topics are, just kind of browse through it. Even some really fast browsing through the table of contents even in a section like that is really helpful for when you come to class and do the lecture. You'll automatically have a good idea in the back of your mind of what the topics are. There'll be a lot more mental traction when you see some of these concepts coming up again. And to do the reading, that's going to be the e-text contents button right here. If you click on this button, it pops out a whole bunch of stuff. It's kind of interesting. If you click on chapter 2, it takes us to the homework, quizzes. There won't be any quizzes in the system. Something about a study plan. It feels like we're off the wrong track. So I feel like the way they implemented this textbook is pretty confusing. So here's a better way to get into that textbook. Once you're in course home, click on e-text contents. And this is where you want to be, Pearson e-text. It's kind of tricky in a way to just find the textbook. It's almost like they're hiding that thing for some reason. Click on the e-text. And now we're just waiting for the textbook to load. It's kind of a weird reality in 2026. I was last on page 99, so that's why it says go to page 99. You may click on probably table of contents, more likely than not, the first time opening the textbook. Scroll through this left bar right here, and here's where we're at, chapter 2. If you click on this, this is the start of the chapter 2 book, and this is pretty much a very verbatim recreation of the actual physical hard copy textbook. So this is just basically the PDF version of it that you can scroll through. Reading through this, or even just skimming through this, is going to give you a good idea of what we're doing in this section. Let's keep on going through there. Click right. And this is pretty much what section 2A is all about. So this is what the textbook looks like. If you wanted to, you can go all the way back to exercises 2A to see what the problems actually look like in this set. But I wouldn't be too worried about doing these particular exercises because that's what the actual homework set is all about. It's just a selection of some of these problems, not all of them, that's going to correspond to the problems that we actually physically do in class. Well, that's a pretty fast tour of what's going on in my lab. Like I mentioned, we're going to talk about this a lot more once everyone has a chance to click on this button right here and get registered. But any questions or comments at the moment about the textbook or otherwise?
There was a chat that asked, once you start a homework assignment in my lab, can you save and come back to it later?
Well, thanks for telling me about that. You know, one thing that's also tricky is, let me show you another thing that I just discovered that happens. I'm going to get to that chat right away, but for the person who sent that chat, sorry about missing it. Here's what my screen actually looks like right now. The chat's up there. I have to physically put my mouse up to that location. Here it is. And then when the mouse is there, let me take a better screenshot. Just want to give you an idea of what it looks like on my end. When I put the mouse here, then it pops out and lets me know if chat exists. That's kind of rough in a way, so I'll try to be a little bit faster to spot those. Thanks for setting that chat. Let me pop that open. So once you start a homework assignment in my lab, yes, absolutely. You can save it, come back later at any time. And just to go along with that question as well, thanks for asking about it, Echo. As far as the MyLab homework goes, really it's fundamentally 100% for practice. I mean, it is worth a course score, but it's for practice in the sense that if you miss a question, you're not going to be penalized on this. You just get another opportunity to try again on the problem. There's unlimited tries. So even if you miss a question a lot, you're not going to be penalized in any way. You can work an assignment, just a couple problems. Everything you put in there, once you hit enter to submit the answer, it's going to automatically save and record your progress right at that point. Other questions about that so far? Okay, again, thanks for asking that question. And let's see here. Any other questions at the moment on just getting registered on the MyLab, clicking that link there? Okay, well, let's jump back to the syllabus. Again, we're going to start class talking a little bit more about MyLab, but this is kind of an overview of just all the things and tools we're going to be working with, getting started. So back to the syllabus. We talked about the MyLab being for practice, but it's also worth part of the course score. So we might as well scroll down here to the big table on grading. How much is MyLab worth? 15% of the course grade. The exams, there's going to be 3 in total, are 15% each. So the homework here is worth essentially one entire exam outright. The better you're able to stay caught up on the MyLab homework, however, the more sense the exams are going to seem. In fact, I have a pretty interesting process when it comes down to just doing all this kind of stuff. When I build out, say, the notes that we're about to take a look at the end of class, my process is the very first thing I do is I go into MyLab and I just take a look at the exercises and what exercises seem to make the most sense for the section. Once I've selected the exercises, then I write the lecture notes. And those lecture notes are the notes that you'll see right down here. So these notes down below that we'll be going through, they're based very, very closely on the actual homework exercises you'll be doing in MyLab. So once I have those written, then back to the syllabus. When I start writing out either a quiz or an exam, I've been keeping in mind the problems that were assigned for the MyLab, the problems you're actually doing yourself, as well as the problems that we actually did in the lecture notes as well. Those problems are going to be possibly, say, changed a little bit to different kinds of numbers. They'll be the same kind of problems that you're going to be seeing on exams 1, 2, 3, as well as the weekly quizzes that we'll be posting. So there's pretty strong parallelism between what you do on your own for homework and what we will do as a class in the lecture notes as well, and what comes up again later on the exams, including the final exam.
Generally, about how many questions do you have per exam? Just an idea.
That is a good question. And it's kind of a hard one to ask, or excuse me, hard one to answer, because sometimes some of the questions are like really fast concept questions. And then another question could be like this drawn out problem where we have to think in terms of context. What is the actual procedure? Say like word type problems that could take a while. So I'd say the best way to answer that is generally I'm going between 8 to 12 questions. But probably a better way to answer that is I'm also thinking about how much time is it going to take the typical student to actually complete the exam in full. So we have a 70-minute block for each one of the exams. That's going to be this part of the syllabus here. But I'm not going to try to write a literal 70-minute exam where you are every single minute writing that 70 minutes, that's the last problem that you just finished off. I think that's kind of rough and kind of brutal. Instead, what I'm really trying to do is write an exam that's about 55 minutes in length, really, for the typical student that's prepared in the sense that you've gone through all the homework, you've been keeping up with the quizzes. It's going to be about a 55-minute exam, really, for the typical students, with the extra 15 minutes just to give you some extra time to pause between problems, double check your answers, and that kind of thing. So the exams, I'm not going to go for long ones whatsoever. They're going to be pretty well controlled in terms of problem numbers and the exam length. I'd say the best rule of thumb is plan for about 8 to 12 questions. And along the similar topic, As far as the exams go, when we get really close to this week down here on Canvas, February 9th is going to be our first exam. So probably before we even get to this week, I'll start putting in more information of exactly what's on the exam. What sections do you have to be familiar with? And I'll also be posting exam review questions down below so you can get a really good idea of what does a typical exam problem even actually look like. But thanks for asking about that, for how many problems to expect on the exam. Any additional questions along those lines or otherwise? Okay. Well, where are we on the syllabus? We're jumping around a little bit, but that's okay. We were talking about the course text. Next up is, this goes along with exams as well. We have a calculator policy for this class. The calculator policy is nothing too major. The calculators are wide open except for graphing calculators like, say, the TI-84 or other more advanced graphing calculators cannot be used on exams. We can't use cell phone calculators or calculators on tablets and so on. But if you have a basic scientific calculator, I gave two examples of what I mean by a basic scientific calculator, the TI-30X2S or the TI-30XA, then that's going to work really well in exam. And just to give a visual on those, let me show you what those look like. So the TI-30XA is kind of an infamous calculator because it's used so often in like lab type courses. This is what it looks like right down here, the TI-30XA. Way more screenshots than I actually wanted. But this calculator is going to do the job for everything that we do in class. If you have something similar to this one already, doesn't have to be the exact model number, then you're all set. The one I would possibly recommend as a little bit more convenient calculator to use, this one is kind of tricky because you have to do order of operations in a certain way, but a slightly nicer one to just type in your values and hit enter to get a result is the X2S. Oh, that's not what I didn't want to go to Target. Hang on, let me get out of there. The TI-30X2S. Okay, so this one is the right one. This one's a nice calculator only because you can type in a long line, hit enter, and get a result out a little bit more easily. But again, any kind of calculator, as long as it's a basic scientific calculator like these, will do the job. I put on the syllabus my top recommendation, the TI-30X2S. I think that's a pretty great calculator for this class. If you have something else, like say a Casio, maybe what else are there for calculators, some other model, and you're not sure if it's going to be allowed for taking exams, just take an ordinary cell phone picture of it, send it to my ISU email address right here, and I'll be happy to take a look at that calculator for you and let you know if it would be a great one for the class or if you need something different. Well, that's our calculator policy. Any questions at all about the calculator itself? Okay, my recommendation for the calculator is try to pick out a calculator that you like, that you're pretty fluent with, that you think is not going to be a chore to work with on a day-by-day basis, and make that your, say, number one calculator that you're always going to use to do math for Math 1123P. That way you become really ultra familiar with that calculator and take that same calculator with you to the testing center, and you'll be in great shape. Okay, well, I'm going to leave this part right here to your reading because I feel like the course description and the objectives, they only really truly make sense once we've done some of these topics. So I'm going to leave this up to your reading. We talked a little bit about the online homework. We'll talk about it a lot more once we come back on Wednesday to give everyone a better chance to say register, play around in there, come up with questions you might want to ask when we come back on Wednesday. So next up is the quizzes that we'll be having. Weekly quizzes. So the quizzes, really, they're not meant to be anything too major in this class. I'm going to assign a quiz weekly. Probably not this week. We'll start our weekly quizzes on week 2, only because week 1 is really busy. We're trying to get everything figured out. We're trying to get the homework system, MyLab, all set up and all that kind of stuff. So I feel like throwing quiz on week 1 is just making week 1 a little too busy. So I'll remind everyone about quizzes on week 2 once the first one is posted. Essentially, this is what quizzes are meant to be. They're not meant to complete with the online homework because, I feel like that's a good amount of work already. I don't want to take up a whole bunch of your time by, say, doubling the length of the homework. The quiz, however, is going to be really short. Basically, one question, maybe it could have 2 or 3 different parts for that one question. And it's just your opportunity to write out some math, send it in to me, and I can grade your work, give you feedback on how you're doing on that question, if you're showing enough work, if you're making any interesting small mistakes to be aware of, and those kinds of things. It's really a major goal of the quizzes is to kind of connect what you're doing in the online homework, which is doing math in an online homework system, which sometimes does feel different. It's connecting to what you're going to be doing on an actual exam. So the quiz questions are meant to be giving you a feel for what a real exam question is going to look like. Well, we'll have weekly quizzes. I'm going to drop the lowest 2 quizzes at the very end of the semester. But any questions so far about the quizzes? Okay. And again, I mentioned the quizzes, they're not meant to be a big deal. There's a couple purposes for the quizzes to see how you're writing out your math, to give you some feedback, direct feedback on if you took enough steps and those kinds of things, or if it was a real exam question. The other purpose of quizzes is it's really just a participation credit in a real sense. The quizzes are take-home quizzes. I'll give about a week due dates once they're fully assigned. So that way you can have a chance to really work the problem, ask me questions if you like. And the quizzes, again, because it's a participation credit, I'm not too worried about if you're working with others in class. So if you're looking at the participation list and you recognize any names, if you want to reach out to someone blind, study partners work really great for this class, and you're welcome to work together on quizzes. Only thing I ask is that you write up your solutions on your own. And because it's a participation credit, I don't grade these ones severely. Every one of them is going to be worth 10 points. You get 5 points default by just handing it in, that's participation. And the other 5 points are for correctness on the quiz itself. And so usually, if you're just doing your quizzes, this portion of your class grade, this 10%, is probably the easiest 10% to get in the entire semester. It's really just keeping up with the course, doing the quizzes as soon as they come up. So if you're keeping up with the MyLab homework, the quizzes, well, it's just going to be pretty straightforward. It's going to be stuff you've already seen. When you go to do the exams, it's going to start to feel like deja vu. The problems aren't the same, but you've done the same kind of problems on both the homework and the quizzes. And when you go to do the final exam, again, it's not going to be anything nasty or awful. It is a comprehensive exam. But it'll be just the kind of stuff that you saw already in exams 1 through 3. So kind of just a rehash of those concepts. So that's what the quizzes will be all about in this course. We'll start our first quiz on week 2, however, so we'll have to remind ourselves once we're on week 2. And this is pretty much the entire syllabus at this point. Any questions at all so far?
I have a question. On the exams, you had sent an email saying that those are going to be in person. Are those like on the days of our class, or is that like a separate day, or how does that work?
Oh, that's a really great question. Thanks for asking about that. I think I was going to forget to mention it without that reminder. So the exams are going to fall on this schedule here. And yeah, when we have an exam, this is a day that class actually doesn't meet. So Monday, its whole purpose is just getting through exam 1. Same for exam 2, exam 3, and the final exam. And the reason for that is I feel like if I'm asking you to do a 70-minute exam, and then additionally, we have a 70-minute class, that's more than you signed up for. That starts to look like a 5-credit course, not a 4-credit course like we're doing. 4-credit course just means you have a 70-minute commitment in person 3 times per week. And I'll never double it up by doing both an exam and a lecture at once. That would be a really, really busy week. So any questions about that at the moment? Okay, and that's one of the things that's kind of weird about this online course. The math department doesn't have any good system for proctoring the exams across Zoom. So the department, the mathematics department as a whole, has required every single one of their courses as a department policy to be in-person exams. And that sounds kind of weird at first, being an online class. Essentially, what I'm going to do is either at the end of this week or possibly at the start of Monday next week, once the schedule has been probably a little bit more stabilized. Don't know what I'm trying to do there. Thought I was just trying to highlight that. There we go. I'm going to email everyone individually through the Canvas system, asking you for your preferred location to take the exam. It could be in the Idaho Falls campus, it could be on the Pocatello campus, and it can even be a little bit more far remote, like say Twin Falls campus, the Boise State University campus, and so on. Once we have all that figured out, as we get closer and closer to an actual exam, again, probably around this week, I'll start sending out information instructions, letting you know how to schedule your particular exam. And exam scheduling is pretty wide open. It can be scheduled for any time on Monday. So it doesn't have to be right at 6 o'clock when our class runs. If you feel like you do better scheduling it for 1 o'clock to fit your schedule, that'll work out just fine. I'll include some flexibility as well, since if anything comes up that causes some hardship on scheduling that exam on Monday, I'll allow it to be scheduled on Tuesday or Wednesday as well. So there is a little bit of flexibility on scheduling your exams. Well, that's a lot of material to think about so far. Again, this is just kind of an overview of how the course will run. And when we get really close to exams, we'll talk about some of this information again, just as a refresher and a reminder. Other questions so far? Okay, well, this is pretty much our day-by-day syllabus. We're going to try to keep close to the schedule as much as possible. But if, for example, we decide we need to take just a little bit longer in section 2, part A, we'll take that time. So this is not a firm schedule, except for the exam dates, which are firm. And it's kind of a weird organization for the book. I felt like this is kind of jarring. When you see something like 5B, it means we expect on Wednesday of the week of March 2nd to be in chapter 5, section B. So that's all that's being mentioned here. We'll do a full-on review ahead of every one of our exams, which should be pretty helpful. And for the not the last week, the close to the last week, the penultimate week, we'll essentially be finishing off our last section, hopefully 12B if we stay on target, and then spend the last 2 days reviewing for the final exam. So again, final exam is not meant to be anything major. It's worth 30%, and it is a 2-hour exam, but I'm not going to try to write a long exam where you're writing for 2 hours like we mentioned on exams 1 through 3. Pretty much if you're doing really well on keeping caught up with the class, coming to class, reading the book, keeping up with homework and quizzes, and you're doing well in the exams, the final exam is not going to be a big deal. And if I happen to personally write a final exam that is just a little bit harder than I intended, the course score suddenly drops after the final exam, this is the one exam I probably would curve because that's not my intention. Pretty much whatever your grade is at the end of exam 3, if you keep working at that same pace, you should be getting that same grade or better after the final exam is the intention. Well, we did, folks. That's about 33 minutes of talking, the entire syllabus, except for the last page here, the university resources. These are all statements that was written by someone other than me, someone in the university. And if you've seen these kind of statements before, that's really kind of the same sort of stuff. You might want to refresh your understanding of some of these things, like say the Title IX law, academic complaints and grievances, all this stuff is really pretty important. If this is maybe your first semester at ISU, I would take some time out of your day and just carefully read through all of it. I know that sounds kind of terrible, but there is really important stuff you should just be aware of being an ISU student. For example, let's just take something random, academic complaints, grievances. If in any one of your classes, this class or some other class, you feel like something happened, which just isn't quite right, there's a whole procedure for addressing it. First meet with instructor. If it's this class, that would be me. We'll try to resolve whatever the issue might be, but you don't have to take what I say for an answer. If you feel in your heart that something isn't working right in the class, there's something that is just quite unfair, for example, you can always escalate. You can escalate next to the department chair. Not sure what I'm trying to highlight here. You can talk to the department chair. You can talk to the dean of the College of Science and Engineering. You can escalate this all the way to the provost. And you yourself would know if this is something that really has to be escalated. So again, that's just one little block here. It's good to be aware of all this information. And some of the statements are also possibly duplicated here, institutional syllabus statements. So these have been put mandatory on everyone's Canvas course page. So probably another thing that's good to take a look into. Well, let's take a moment to catch our breath. Day one is kind of weird because it's hard to know how much to talk about and how little to talk about, since too little information makes a course seem kind of mysterious. And talking too long, well, it starts to become kind of a droning thing. It starts to get hard to retain everything. But any particular questions that folks have right away at the moment?
I have a question.
Yeah.
Like before we come into class, are there like, do we need to have already read, like, say we're going to do section 2A tomorrow? Do you want us to have already read section 2A prior to class, or is that something that we go over while we're in class?
Well, thanks for that question. Yeah, I'd say the golden standard for doing a math class is take a look into the syllabus, or maybe more accurately, take a look at what's going on in Canvas. I'm always going to have a document right here with exactly where we're at. It'll be that chapter and section we're in. So we're about to do chapter 2, section A. And what you said is what I mentioned, the gold standard. If you have the time, if you read all of section 2A, then that's going to make the lecture the most useful for you. That'll give you a lot of traction on your mind when these concepts come up. They won't be the first time you've seen them, and they'll make a lot more sense when we do them in class. But sometimes we might find that that is a hard standard to stick to, especially if you're taking lots of credits, say more than 12, or if you have other obligations, family, work, friends, that kind of stuff. If at the minimum, let me see if I have this open, I still do. If at the minimum, before you come to class, if you open up section 2.A, I guess they call these units 2.A rather than sections, and just browse through it, seeing what the information is about. Maybe take a look at a couple examples that are going to be solved, see how it works. And even just some really fast, light browsing, 5 minutes to about 15 minutes, that's going to help you out a lot, so that when we go into the lecture, it won't be the first time you've seen that information. So yes, I would say it would be excellent if you came to class already familiar with what we're about to talk about. It might not be attainable every single day, but try to make that something as a big goal, and class is going to be a lot easier to get through. So really, probably the best process for the typical student is before class, skim through this section, see what it's all about. Then when you come to class, to participate in class, there's a couple other things you can do additionally. If you open up this file right here, this 2A, understand, solve, and explain, by clicking on it, takes you to a PDF. And you can print this out. It's basically like a worksheet at this point for the problems that we're going to be solving throughout the course. So if you have this in front of you, the helpful thing about this is you don't have to copy down all of this information here. That's going to be writing really, really fast. Your hand might be pretty tired at the end of class. It's good to have just this information available. So if it's printed out or maybe just loaded up on a separate tablet, a separate tab on your screen, something like that, you'll know what we're about to solve. So some people might just have this on a separate screen. Some people might print it out physically. Or maybe you're using a digital pen like me, and you just download this and start drawing on it like we're about to. Say, solving this, it's going to be equal to 1 overall fraction, and we'll write in the result as we go. So putting that all together, Great way to run through this class to participate in it is read the section, download the notes here, then we'll work through them together as a class, going from problem by problem. After we complete this entire section, then it would be a good idea to go back to the section 2A and try to read it more in full. Reading everything, it would be great if you can get through it. But even if you do just a little bit of light skimming, seeing how the examples go, that's going to help out a lot. When I say read the section, there's a lot to say about just reading the section as well. Be careful how you scroll. So if I'm reading through this section, imagine I just read through this block of text here and come to example 1. Scroll down to just this part and stop the moment you see solution. Here's the actual entire question. The more actively you read this, the more easy it is going to be to connect the dots with this information and really learn from it. Take out a pen or pencil and start trying to solve this on your own. If you get stuck at any point, then start looking at the solution. In other words, doing the solution, if this is all you read, it gets really, really hard to internalize what the textbook is actually trying to say, unless you're also trying to work the same problem in parallel. You might have got it started, but maybe you missed this part right here. So you'd read to this section and then start solving the rest of the problem. And then that's a great way to read this kind of textbook. So after you've read that section, there'll be usually a quiz at the very end down here that you could give a try. We're skipping it on week 1 since it's a busy week. After you're done with the quiz, just go back to Axis Pearson, go into the MyLab system, and then that'd be a great time to start solving the problems. Well, other questions at the moment? Okay, well, we're at the part of the course where we're ready to begin and start in earnest to get a feel for how all these classes are going to go. So just a couple more resources on Canvas. Everyone's found this link, so we don't need to say anything about this. But after class ends today, I'm going to go into YouTube and put our lecture that we're recording right now into this playlist folder right here. So if anything happens with your technology, maybe you joined class a little bit late, that's okay. Everything we did right at 6 o'clock is the official content. It will all be recorded. These are just 2 optional articles you could take a look into, some motivational information on mathematics itself, and some good study tips for studying mathematics. And then the other thing I do after we finish our work for the day is I save the work that we have done and I'll post it here in Canvas. So this document keeps changing. It keeps getting uploaded and updated until the whole thing is fully solved. And that can be kind of inconvenient because if you didn't get a chance to download a blank version or print it out if you wanted to print it out, this one becomes just completely marred up with all the solutions we post. That's what this file is all about. So if you need a clean version of any one of the section notes, click on here. And here's where you'll find them. I'm going to duplicate the file types. So the PDF is just the most compatible version. If you want a Word document, like the Word document that we're about to use, this is that version here as well, which might be a little bit easier to work with digital tools. So that's the setup so far. Everything that you see here on Canvas, I have duplicated over here on the thumb drive as well, but usually as Word files. So here's what the section 2A lecture notes look like. So our goal is to get through this content. Everything we put here will be saved and uploaded later on. And I guess we're just about ready to start. Any questions or comments at the moment before we begin the actual course content? Okay, well, let's begin. The section, that's really unit. I'll probably say section to mean unit 2A. It's about this idea, understand, solve, and explain. We have a good amount of word problems in this section, relating to things along the lines of areas, units, conversions in different kinds of plausible real world scenarios. But really to get to those kind of interesting questions, there's just some background that we have to kind of just brush up on dealing with some fraction arithmetic. It comes up a lot in this chapter. So think of the first examples that we're going to look into, multiplying, dividing, adding and subtracting fractions, as kind of just a getting everyone all on the same page kind of content. Some people probably are pretty familiar with these. Some people are also possibly quite familiar, but you just need a bit of a refresher to remind yourself how this all goes. After we get through the first bit of dealing with the fractions, then we'll get into the larger problems with the units, dealing with the understand, solve, and explain content. And this is basically how my notes are going to be organized for the whole semester. I'll say where we're at. Usually there's going to be something here, maybe a definition or a procedure, something along those lines. And I put a little break here to say, after we talked about the concept of multiplying fractions, the immediate thing we must do is practice it. So the related example is always going to be directly below. I'll try to give us a lot of opportunities to practice. So there's several versions here, but let me hide this one so that there's not too much going on. And this is pretty much what the experience is going to look like. Just as another reminder for this class here, best way to get through this online class is to have definitely kind of a bigger monitor. You wouldn't want to do this content through a cell phone, for example. It's going to be really, really hard to see things. And there's a limit to how much we can blow things up and zoom in. So if the cell phone is all you got, maybe there's a problem with the computer. I mean, that's better than nothing. But definitely you want to have a laptop, desktop, maybe even a tablet of a decent display width so you can see everything clearly. And while I mentioned that, I should ask myself, is this large enough at, say, 140% zoom for everyone to see? Okay, well, let's begin then. For the fraction arithmetic we're going to go with, usually you'd think you're going to start with addition, subtraction, but it turns out that's kind of a chore when it comes to fractions. So we'll begin with multiplying fractions. So to multiply fractions, it says, write the product of the numerator over the product of the denominators, then simplify the resulting fraction if possible. So that's it. That's the whole procedure. But if you're like me, that sounds really foggy and vague. Some people can take written information like that and just visualize it in their mind. But for me, I have to see it. Everything that's written above is essentially captured right here. I'm multiplying the fraction a over b against the fraction c over d, and the procedure above tells us multiply across the numerators, multiply across the denominators, then simplify the resulting fraction if possible. For this to work out, we have to have two things happening as well. It's required that the denominator b and the denominator d both cannot be 0. And the reason for that is anything of the form a divided by 0 is undefined, which is kind of a weird word. Well, all it means is that it's not a number, is a better way to say this. Division by 0 results in a non-number expression. Well, that's the procedure. But one thing that's also kind of frustrating about mathematics is when you go to do the actual problems, there's a lot that's kind of assumed that it's not always said every single time. It's assumed that we'll always simplify the fractions. Well, any numbers that we produce, we always want to simplify. So that's one thing that's not quite expressed exactly. I wrote this question pretty similar to in the homework. So it's assumed that we'll simplify. If you forgot to simplify in the homework system, MyLab, and they wanted a simplified answer, not a big deal. The system is going to alert you. If you forgot to simplify this, and this is an exam question, well, it's not the worst thing in the world. I mean, you might lose some points, but I grade on partial credit. If this is a 5-point problem, You worked it out correctly, but you didn't simplify, you might lose 1 point, nothing too major. Okay, let's start this off. 3/8 times 12/15. That's not something I would have any clue what that quantity would be. The procedure says to multiply across the numerator and the denominator, but that's one thing that's a little weirdo as well about these kind of problems. For going for a simplified answer, that's not what we actually always do in practice, which is kind of frustrating. Let me write this down a second time to really visualize this. 3/8 times 12/5. You know what? It simplifies right here, right as you're staring at it. And if you simplify now that the numbers are smaller, it turns out it's a lot easier to work through the whole entire problem. So instead of multiplying and getting 36 in the denominator, divide by 40 in the denominator. I think I said that wrong. Instead of multiplying across and getting 36 in the numerator and 40 in the denominator, which you then have to simplify, you could simplify right here just like this. We have a prime 3. It doesn't divide 8, so I can't do anything there. We have a prime number 5. It can only cancel into a numerator, but it can't divide into those evenly. But between 8 and 12, we can divide. 2 divides both 8 and 12, but why not go even further? 4 divides both 8 and 12. We don't want to go further because we don't want decimal numbers. Let's divide this by 4. 4 will go in here twice, go in here 3 times. So what we did on this part right here is to simplify our answer, divide by 4, both here and here. Now when we go to run through this procedure, A times C, the A is a 3, the C is a 3. We're really just doing 3 times 3 for a 9. Those were across the numerator, so we need a fraction bar now and do the same across the denominator. Here we'll just take 2 times 5 to result in a 10. So that is one way to do it. Any questions about that so far? Okay, lots of ways to do these kinds of problems. And again, if you did it this way, let's call this method 2. There's nothing wrong about it. There just might be a little bit more work to simplify. Notice that this fraction is already simplified because the divisors of 9 would be things like 1, 3, and 9, but none of that divides 10 evenly. If you went this route, 3/8 times 12/5, and we followed the concept verbatim, just as it's written down on paper, we would multiply across the numerator. That would be 3 times 12 to get us a 36. Then we would have to also multiply across the denominator. That'd be h times 5 for a 40. This answer is not fully correct. We have to still simplify it. I think it's tougher to simplify right here, for me personally, than it is to reduce the problem right here by doing the divisions. But once you get here, notice 4 divides both the numerator and denominator, just like we divide by 4 here. So we can simplify doing that same step. Let's take it here. Divide by 4. And instead of saying numerator and denominator, I'll say in top and bottom. That's just a faster way to say it. In order to reduce the fraction, so if we divide by 4 here, we'll go in 9 times. Divide by 4 here, we'll go in 10 times. And so our result is 9/10, however we decide to visualize it. But we did it, folks. This is our first bona fide problem of the course. Our goal is to finish up these notes at the very end of this week, but we'll take our time with this. Multiplying fractions is not too tough of a concept, but in the later on problems, it'll be really well worth the effort to do all of these concepts very carefully. Any questions or comments at all, seeing either method? Okay, well, let's try out another one down below. Part B says, take 10 times 3/5. That feels a little bit funny because when you see 10 times, sometimes the worry is, Where are we multiplying? Are we multiplying on the top? Are we multiplying on the bottom? This structure right here doesn't seem to really fit in, but you know, you have a lot of options when it comes to numbers like this. 10 is an ordinary integer, but 10 can also be rewritten in a lot of different ways. You can turn it into a fraction just like this. 10 is the same as 10 divided by 1. And even though that step is not required, sometimes it's a good step to take just to connect the concept with the idea right up here. So if we take that extra step, we can turn the problem into 10 over 1 times 3 over 5. Then it fits this format a lot better. We actually have a bona fide fraction, a divided by b over here. We can get 35ths if we multiply across the numerators, and no harm done if you decide to go that route. Or we can reduce it right here. 5 goes into 10 evenly, so if we divide by 5 right here, it becomes a 1. Divide by 5 right here, it becomes a 2. So now at this stage, we're left with, following the procedure, multiply the 2 by 3 to get the numerator, 6. Multiply the 1 times 1 to get the denominator, 1. And here we have it, 6 over 1. But how do folks feel about that answer? Anything you'd want to do with this additionally? Can anyone see what the next step ought to be?
You would want to make it a whole number since that's what 6 over 1 is.
Yeah, exactly. You know, I wouldn't be very, very picky on this. If this was a problem that you did on an exam, again, you might lose at most just 1 point. It's not considered simplified because, just like you said, 1 divides everything. It goes into a numerator, whatever that numerator is, many times. So 1 divides into 6 times, and this is the better answer altogether. So if you wrote it like this, it's not going to really hurt you that bad on an exam. MyLab is going to remind you that it does need to reduce. And this is the answer that we're going for, just a 6. Well, any questions at the moment, folks? Okay, another concept to mention is when you go to write these problems out, you do have to show your steps. And you know, that's something that's easy to forget about when you're doing a lot of homework in MyLab Statistics. When you're doing the homework in MyLab Statistics, it's a good idea to just grab an additional piece of paper, pretend like it's a real quiz or exam problem, write out the steps, and then just put in the answer once you get to it. If this was a real exam, you don't necessarily have to put a box around these. Some people just like to do that as a force of habit. So if you have just gotten used to boxing out your answers, that's possibly just the public school system training that we got drilled into our head. No harm done. Sometimes I'll box my answers like this, especially if I feel like it's hard to see where the answer even is. But one habit that's really important in mathematics, the more and more math you take, the more important this becomes, is this. If you're already saying what your answer is equal to, you know, I don't need a box in that point because I'm going to be reading your work, however it looks, going left to right, top to bottom, following the equality symbols. So if this was, say, a real exam question, I'm going to watch for your equality symbols and see how the problem tracks. I'm not going to take off points if you forgot your equalities, if you didn't write them in, but it's good to just see what is the flow of the problem. This is really together just one big sentence, and the equality sign is the verb. It's essentially the most important thing that you're going to write down. A sentence without a verb is kind of a strange statement altogether. This says 10 times 3/5 is equal to, after simplifying, 2 over 1 times 3 over 1, which is equal to 6 over 1, which is equal to 6. And if your work flows like that, you really don't need a box at that point. So for each one of these problems that we're writing down and solving in class, I'm trying to write it along the lines of what would a typical student do in a real exam setting or for a quiz, trying to show a reasonable amount of work. You might have not have showed every single one of these steps. You might have gone from here directly down to a 6 after you had the 2 over 1 or 3 over 1, but you will need to show some steps, and getting in practice on doing that is a great idea. Well, we're on to the last problem down below. Here's where the numbers get a little bit more gnarly. As we're seeing here, there's negative signs all over the place. We have slightly bigger numbers. But, the first concept that occurs is a negative number times a negative number results in a positive. So these negative signs cancel out. If there were 3 negative signs in this problem, we would have ended up with a negative fraction. But with just those 2, really all we're doing is 28/16 multiplying 8 49s. No negative signs now. They have canceled in pairs. If there's 4 negative signs, all of them would have canceled. And if somehow I had 5 negative signs stuffed into this problem, that's kind of overdoing it, then we'd have just had 1 negative sign left over right at the front. So first thing we'll do is cancel signs. Next thing we'll do is start multiplying. And here's where simplifying first starts to become really, really helpful. If you multiply 28 times 8, you're going to get large number up in the numerator, 16 times 49, an even larger number in the denominator. And now you have to simplify something that's something in the hundreds divided by something in the hundreds. That can get pretty tedious quickly. But notice what we can do in this problem. We can reduce from here to here. That's probably a bad color. We've used blue already. We can reduce from here to here. 8 can divide into itself once and goes into 16 twice. So that's a big simplification. There's more we can do here. Anyone see another simplification to take?
You can simplify the 28 and the 49 divided by 7. So that would be 4 and 7.
Yeah, absolutely. 7 goes in here 4 times into 49, 7 times, just as you said. And we can do even more. We can cancel even further. If you canceled right now, yeah, exactly, Amy. You could divide this 2 into the 4. If you did it right now, that'd be great to do it just at this step. I'm going to take an additional step because you might notice once we start canceling things, it just gets visually pretty messy. So let me carry in what I have so far, 4 halves times 1/7. Now let's do that last suggested cancellation right here. Again, you could do it all at once, right in this step here if you prefer. But sometimes I'll take an extra step on the notes just to make the notes a little bit more friendly to read. If you ever came back to here and I did like a million things on this line right here, it would be hard to watch. You'd have to watch the video at that point to see how it was done second by second. So over here, like you said, we can divide by 2 here. It goes in once, goes in 4 twice. And now we're just about done. Multiply across the numerator and we'll get 2. Multiply across the denominators, that's a 1 times 7. And we get 2 7s. So that's our work, our answer, and our work is done right at that stage. So kind of the punchline to part C is about negative signs canceling out. It's also a reminder that canceling in the middle sometimes is a really good idea just to control the size of the numbers. In fact, let's take a look at how big those numbers would have gotten. A calculator I'll often use in class is going to be the Desmos calculator, which is weird because this is not a calculator we could actually use in an exam setting. You have to use, say, a TI-30XA or similar, but this just turns into a great calculator to pull up while we're in class. So desmos.com is where we're going. We want the graphing calculator. So I'll often go to this website just for a really fast in-class calculator. And what I want to just demonstrate is, what if you did multiply across the numerator? You would have had 28 times 8. If you multiply across the denominator, 16 times 49. You're dealing with 224 divided by 748. And it turns out that fraction, 224 over 748, is going to take a long time, a lot of effort to get down to 2 7s. It will get there, but that's a lot of work. So simplify first, then multiply across numerators or denominators, and it turns out that's going to be the faster approach. we have a lot more to do these notes, but this is kind of like our warm up for the class, just getting started. Any questions at all with the problems we've done at the moment? Okay, well, we don't have any homework at the moment, but I wanted to show you what happens after class is over, because sometimes that's pretty important too. Once class ends, the first thing I do is I take this file, I go to the Save As button, and usually I'm a little bit faster at finding where this is going to go. There we go. I click to a PDF to convert it over. Let me close this as well. Then once I have that PDF built, I take it and I drop it right here. So I'm going to delete this one. This was the blank lecture notes. It's no longer blank at this point. And from over here, this is kind of a nightmare to navigate. I preferred Moodle, if you remember that system, but Canvas does work. This takes a little bit extra work to get to where we want to go. Okay, finally, here it is. And this is what's going to happen at the end of class. It's not the same file any longer. Everything that we do in class is going to be re-uploaded right here. And this impacts how you take notes as well. You don't have to write down everything like we mentioned, because the ideas and everything that we write down is going to be uploaded right after class. So if you're a person that does fine with just lined notebook paper, take out a piece of paper, label the section. You can solve it by hand along with the class as we go. Or you could print out the notes, work on them digitally like we've been doing so far. And all the results are always going to be uploaded here. Essentially, Canvas is going to just turn into one big set of resources. If you need blank notes, you can see it here. And the last thing I'll do before class ends, or excuse me, after class ends, is I put the class recording right here in the recorded lectures. I'll try to end class usually pretty close to 7:15. Today, we could go a little bit further, but I feel like week 1 is a pretty overwhelming week. We're kind of exhausted doing this already, possibly as a night class. I do have some homework for you to do before we come back to class on Wednesday. Click on the Access Pearson, get started on the MyLab. Possibly, if you haven't done that yet, right after class would be a good idea. Then on Wednesday, we'll talk a little bit more about that system, MyLab, demonstrate how to do homework inside of it and that kind of stuff. But any last questions at all, folks, before we call it a night today, just a little bit early? Okay, well, have a great evening, everyone. Thanks for everyone making it into class today. When we come back on Wednesday's class, we'll pick up right where we left off, example 2 here, after demonstrating the MyLab homework system a little bit better under Access Pearson. But have a great night. If any questions come up whatsoever, if you get any kind of weird issues that come up with registering, don't hesitate to send an email right away. You can send an email through the Canvas system, which is the inbox right here, or just to my ISU email address in the syllabus. But have a great night, folks. I'll see you all on Wednesday's class.
Thank you.
You bet.
Thank you.